Example 2, it says find the area enclosed by the curves y equals x squared and y equals 8 root x as shown below. So the area that we're trying to calculate is the area between them. So that's the area in red that we're looking for. Now, we have our little formula. Remember, the formula for calculating the area is such that we need to know which curve is on top and which curve is below the area. So clearly, y equals x squared is this curve. That's underneath the area, that's below it. So that's going to be in the bottom. And the other curve, y equals 8 root x, is clearly the one that is above the area. So that's on the top. The other things that we need are, remember, we need the values of x that the area lies between. So we clearly know one of them, that's going to be 0. So the area starts there, and the area ends here. So the area ends at this particular value of x here. Now the problem is we don't know this value of x. We're going to have to work it out because these are going to be the limits of our integral. Now this value of x is the x coordinate of the point of intersection of these two curves. So we're going to have to find it. So what we're going to do first is get the limits. So we need the limits for the integral. And those are going to be the x coordinate of the points of intersection of the two curves. Okay, so our two curves are y equals x squared, and we've got y equals 8 root x. So label the two equations 1 and 2. So because y is the subject of both, I'm just going to take equation 1 and sub it into 2. So we're going to sub 1 into 2. Remember when it was a straight line in a curve, we would have made y the subject of the line, then subbed it into the curve. Well, we've just got two curves here, but it's the same idea. Y is the subject of one of them. In fact, it's the subject of both. So we're just taking one and subbing it into the other. So we're going to get x squared is equal to 8 root x. Okay, plan then. So what I'm going to do is I am going to get rid of the root and bring this 8 root x over. So we're going to get x squared minus 8x to the power of a half, and that's equal to 0. Now, good news. We've got a quadratic equation. The highest power is 2. Yes, this nasty little power of a half. But just make sure all your powers are positive first, and they are. Okay, there's no negative powers. So what I'm going to do here is I am going to factorize here because clearly there's an x in common, and we're going to lift out the x with the smallest power. So we're going to lift out x to the power of a half. So then open brackets, x to the power of a half times what gives you x to the power of 2. So remember, when you multiply two indices with the same base, you add the power. So a half plus what gives you 2? Well, it must be 1.5 or 3 over 2. And then x to the power of a half multiplied by minus 8 gives you minus 8x to the power of a half, and that's equal to 0. So we have a product of two things equal to 0, so that means x to the power of a half equals 0, or the bracket equals 0. In other words, x to the power of 3 over 2 is equal to 8. Okay, how do we solve the equations? How do you solve an index equation where it's the base that's unknown? Well, all you simply do is take the reciprocal power of the other side. So to make this power 1, we take the reciprocal power of the other side. So we're going to get x equals, so put brackets around the other side and take the reciprocal power. So reciprocal means you flip numerator and denominator, so that's just going to be 2. Or, again, to get rid of the power 3 over 2 and just make it 1, you take the reciprocal power of the other side, so put brackets around the other side. The reciprocal power is 2/3, and we've just got 8. Okay, tidy up, so we're going to get x is equal to 0 squared is just 0, and that makes perfect sense because that's the x coordinate of one of the points of intersection, so the other solution will give us the other x coordinate of the other point of intersection. So, or x is equal to, so 8 to the power 2/3 means we're taking the cube root of 8, and then we're squaring the result. Again, you can put the power 2 outside, or you can put the 2 underneath the root, it doesn't matter. So cube root of 8 is going to be 2. 2 squared is just going to give us 4. So we've got x equals 0 or x equals 4. So we've now got the limits for our integral. These are the values of x that the area lies between. So if we go back very quickly, very briefly to the diagram, it makes sense. The limits are 0 and 4. So now we know the equations of the curves, which are top and bottom, and we know the limits that the area lies between. We can now get the area. So now we're going to write down our formula. So area is equal to the integral of limit b and a of top minus bottom dx. So we're going to chuck everything in. So that's the integral of top limit is 4. It's the bigger limit goes in the top, smaller limit goes in the bottom. Okay, top. So if we go back to our diagram, the curve that's on top is this one. And again, you're only subbing in the non-y terms, so 8 root x and then we're subtracting the bottom. So the bottom is this curve. Again, you're only subbing in the non-y terms, so you're subbing in x squared. Okay. Now we have to get rid of the brackets before we integrate, so we still copy down our integral signs because we haven't integrated yet. So we've got 8 root x. I'm also going to get rid of the root. I'm going to write that as 8x to the power of a half and then minus x squared. So you'll see that there's no brackets, there's no x's on the bottom line, there's no roots, so we've got the green light to integrate. Because we're integrating with limits, we have to put brackets around the integrated expression. So open square brackets. So add 1 to the power, divide by the new power. So we're going to have 8x to the power of 1.5, or 3 over 2. And then we're dividing by 3 over 2. Again, integrate our next term, add 1 to the power, divide by the new power, so we're going to have minus x cubed over 3, and don't forget to add a constant. Close your square brackets, so the expression has now been integrated. This is our integrated expression, and then put the limits immediately after the brackets. So the bigger limit, or the top limit, is 4, and the smaller limit, or bottom limit, is 0. Okay, let's tidy up this mess here. We're dividing by 3 over 2, so that's the same as multiplying by we've talked about this before, dividing by 3 over 2 is the same as multiplying by 2/3. So we're going to multiply 8 by 2/3. So that's going to give us 16 over 3. And then we've got x to the power 3 over 2 minus x cubed over 3 plus c. And then we've got our limits. Okay, so now it's time to break up the square bracket into two separate square brackets with a minus between them. So we're going to have first square bracket and then with a minus, and then we've got our second square bracket. Okay, we're going to chuck the bigger limit or top limit into the integrated expression, and that goes into this first square bracket here. So we're chucking 4 in everywhere we see x. So we're going to have 16 over 3 times 4 to the power 3 over 2 minus 4 cubed over 3 plus c, and then we're going to chuck the bottom limit or the smaller limit into the integrated expression into the second square bracket. So we're going to have 16 over 3 times 0 to the power 3 over 2 minus 0 cubed over 3 plus c. Okay, let's tidy up. So first square bracket, we have 4 to the power 3 over 2. So we're taking the positive square root of 4, which is 2, and then we're cubing it. 2 cubed is going to give us 8. So we've got 16 over 3 multiplied by 8. That's going to give us 128 over 3. And then 4 cubed is going to give us 64. And then multiplied by the minus, that's minus 64 over 3. Then plus c, and then go to copy down our minus, go to our other square bracket. This is all going to be nothing. Okay, nothing to the power 3 over 2 is nothing, times 16 over 3 is nothing. We're subtracting nothing and adding c, so we've got nothing plus c. Okay, so we've got equals, and then our first square bracket is 128 over 3 minus 64 over 3 is going to leave us with 64 over 3 plus c, and then we are subtracting 0 plus c. And again, the c's, the constants always wipe out at the subtraction stage here, and we're just left with 64 over 3 minus nothing is just going to give us 64 over 3. And then again, when you get that, you can hit your Shift SD button. It changes it into an improper fraction, sorry, a mixed fraction, and that's going to give you 21 1/3, and it's going to be square units. And that is our answer for example 2. So you can see example 2 was harder because you had to do a bit of maths first to work out what the limits were, and then you were able to go ahead and integrate.